Hi, I'm Dr. Nathan Kelber with JSTOR Labs. Today we're going to do Python Basics 2. We're going to learn flow control and the basics of writing functions. Let's get started. In Python Basics 1, you learned about expressions, operators, variables, and a few native Python functions. We wrote programs that executed line by line, starting at the top and running to the bottom. This approach works great for simple programs that only execute a few tasks. But as you write programs that get more complex, you'll need to figure out what action comes next in your program. We can control when, or even if, code gets executed with flow control statements. If a program is a set of steps for accomplishing a task, then flow control statements help the program decide the next action. Flow control statements work a little bit like a flowchart. For example, let's say your goal is to hang out and relax with friends. There are a number of steps you might take depending on whether your friends are available or you feel like making some new friends. We can think of this like a flowchart, where each diamond in our flowchart represents a decision that has to be made about the best step to take next. This is the essence of flow control statements. They help a program decide what the next step should be given the current circumstances. Let's take a quick look at this flowchart and then think about how we might implement it in Python. So we can think of each diamond shape as a decision that needs to be made. And so if you're going to hang out with friends, you might ask first, do I have any homework? And if the answer is yes, then you might want to complete a homework assignment and then go back and check and see if you have homework again before you hang out with friends. If you don't have any homework to do, then the answer might be no, and so then we might ask, are friends available? And if friends are available, then you would just hang out with them and relax, and our program would come to a close, right? If your friends aren't available, or then we would get a no, and you could then try to make new friends. If you decided to do that, you could go to class and try to make some new friends, or you could wait until tomorrow and then ask if friends are available again. So you can see that there's a flowchart here that chooses things based on yeses and nos. When we work in Python, we're going to use Boolean values, and those are going to basically be trues and falses. So we can think of a true like a yes and a false like a no. Now, one of the important things to recognize about these Boolean values is they're always capitalized. And so if we try to create a variable like our friends available and set it equal to false with a lowercase f, we're going to get an error. And so we need to use a capital F for that false. And notice when I put in that capital F, the color changed to this greenish color. That shows that we're using the special Boolean value of false. And so once I have that capital F, false, then when I run the code, I can see that the value of our friends available is false in this case. Now keep this in mind too, you can't create a variable called true or false because those are special reserved terms in Python. Often when there's a decision to be made, we need to make some kind of comparison first to get that true or false value. So we're going to use comparison operators to figure that out. So in this case, we can compare two different integers and see if they're the same thing. You may remember this from our last lesson. So in this case, we have 67, and we're going to see if it's equal to 67. And that's going to give us either a Boolean value of true or false, right? And so in this case, it's obviously true. Now, with that comparison, 67 equals 67, we're using two equal signs. So this is an important thing to remember because if we say 67 equals 67, that's different than 67 equals 67. If there are two equal signs, that's a comparison operator, and it's going to compare the two things. In this case, we're actually doing a variable assignment statement, right? And so in that case, we're going to get an error because you can't create a variable that's just the number 67, right? And so keep that in mind. An assignment statement, an initialization statement, whatever you want to call it, always uses a single equals, and a comparison operator uses two equals. So one is asking, are these two things equal? And the other one is literally setting that thing to be equal to a variable name. Now, there are additional comparison operators that can help us with flow control statements. So here are some additional operators. The equals equals just asks if these things are equal to each other. The exclamation point equals asks whether they're not equal to each other. And then we have less than, greater than, less than or equal to, or greater than or equal to. So You can see we have some more examples below. 67 is not equal to 32. So we can ask ourselves, is that a true statement or a false statement? It's going to resolve and it's going to be either true or false, right? So 67 is not equal to 32. We know that. We're going to run this code cell and we're going to get back true. 67 does not equal 67. Well, in this case, that's obviously false, right? Because 67 does equal 67. And so you can see the way that we can form some more complex logic with this not equals to operator. Now we can also do this kind of logic with strings. So in this case we have hello world and we're going to compare it to hello world. They're both strings that are exactly the same and we're going to get true back. In this case we're going to compare a string 55 to the integer 55, and of course we've already done this before. We know that we're going to get a false back. A string cannot be equal to a float or an integer. And then in this case below though, we're going to compare an integer and a float. So we've got 55 and 55.0. When we compare those two, we're going to get true. So we can compare an integer and a float directly to each other. Finally, we can use a comparison operator on a variable. So we can say the number of dogs, and that's a variable that we're creating, equals 1. And keep in mind, this is an assignment statement, initialization statement, so we're using one equal sign. So we create a variable, number of dogs, and we set it equal to 1. And then we're going to do an operation here to see whether number of dogs is greater than or equal to 1. And so when we run that, we're going to get back true, because the number of dogs is greater than or equal to 1. It is at 1. If we put 3 here, we should also get true. If we put, let's say 0, we're going to get back false. So that's the basic way that comparison operators work. So we've discussed Boolean values, that is true and false. There's also Boolean operators, and that includes and, or not. Let's talk about those. We can use those to create expressions that evaluate to a single Boolean value, but they're going to evaluate two things at a time, okay? And so the way to think about this is that there are two conditions that we're going to look at, and we're going to evaluate them at the same time, and then we're going to figure out finally whether all of it is true together or all of it is false together. So let's take a look at and first. The and operator determines whether both conditions are true. And if one of the conditions is false, then it's going to come up with false, okay? So in this example, let's say we have true and we have true. That's going to end up being true overall, right? But if we have true and false, we need everything in this case to be true, so we're going to end up with something that is false. And so the way to think about this is that when it comes to an and operator, we want everything to be true, and if anything at all is false, then we're going to get false. And so here I have an example of a truth table, and this is just for two values. And so if the first condition is true and the second condition is true, then we're going to get true. If we have true and false, or false and true, or false and false, then we're going to get false for the overall evaluation. So using an and statement, everything that we look at, every condition has to be met and every condition has to be true, okay? So an and expression requires all the conditions to be true, and they can easily result in false evaluations overall. That's different from the or operator. The or operator determines whether any condition is true, and if any condition is true, then it evaluates to true overall, right? So in this case, we've got true or false, and since we're using an or in this case, we're going to get true. And we have false and false. In that singular case, we're going to get false. So take a look at the difference between these two different truth tables. Here, for the or expression, if we have true or true, we're going to get true. If we have true or false, we're going to get true. If we have false or true, we're going to get true. And if we have false or false, we're going to get false. Now, see how in this case, with the or expression, it tends to evaluate easily to become true, whereas with the and, it tends to evaluate easily to become false. The Boolean operator not quite simply just flips a true to a false or a false to a true. So in this case, we have something like not true. When we run that, we're just going to get false. And if we were to put in here not false, we would get true. And so let's look at this in practice because we're being a little esoteric here. Let's look at how this happens in an actual evaluation. So we're going to evaluate two conditions at once, and we're going to just use integers here to keep things nice and simple. And so we're going to look, here's condition 1, and it's asking is 3 less than 22? And here's condition 2, it's asking if 60 is equal to 34. Okay, so 3 is less than 22, we know that's true, right? And 60 is equal to 34, we know that's false. So we have a true and a false. Now in this case, since we're using an AND operator, we need everything to be true. And since the first one is true but the second one is false, we're going to get false overall. And that's because we're using an AND. Now if we were using an OR here, we would get true, right? Because the first statement is actually true, and so that would be the evaluation. Now in the second example here, we're going to evaluate these two conditions at once again. 3 is equal to 45, we know that's false. And then 3 does not equal 7, we know that's true, right? And since we're doing an OR, we only need one thing to be true, right? So in this case, we're going to get a true. So if we were to, again, to flip that logic and make that OR into an AND, then suddenly we're going to get false. Because in this case, we need both things to be true with an AND statement in order to get an overall evaluation of true. We can also evaluate multiple conditions at once. So in this example, I've got a whole bunch of different things that are all being done at the same time. This is not usual practice in code, but I just want you to know that that's a possibility. There isn't a kind of order of operations, similar to the way that in algebra you do the exponents first, and then you do the multiplication and the division and then the addition. So in this case, they resolve in the order of not, and then or. So we have 3 is less than 7. Hello does not equal goodbye. 17, the integer, equals 17, the float. And then 2 plus 2 does not equal 4. And so these are all with ands, connected with ands. So in that case, we need everything to be true, right? So 3 is less than 7. That is true. Hello does not equal goodbye. That's true. 17, the integer, equals 17, the float. That is also true. And then 2 plus 2 does not equal 4. Actually, 2 plus 2 does equal 4. So this last value is false. And since we have one false, that means everything is false because it's connected with ands, right? And so that's our final outcome. So let's look at how this applies actually in Python. So we're going to take a look at how to write a flow control statement. The general form of a flow control statement in Python is a condition followed by an action clause. So it's going to be something like in this condition with a colon, and then we're going to indent, perform this action. And the in this condition is usually going to evaluate to a true or a false. So if this condition is true, I want you to perform this action. So remember before when we had that flowchart, we had a decision that was being made, right? And one of the initial decisions was have homework. Do you have homework? And if have homework is yes or true, then you should complete a homework assignment. And so there's a decision being made there, and we're trying to check if something is true. If we write that in kind of like Python pseudocode, it would look something like if have homework, and we're just creating a variable name to store the answer there. If have homework equals true, then complete assignment. So if this is true, then we're going to work on the homework assignment and complete it, and then we're going to move on to the next thing. And so the condition is given followed by a colon. The action clause then follows on the next line, and it's indented into something called a code block. A code block is a snippet of code that begins with an indentation. A code block can be a single line or it can be many lines long. Blocks can also contain other blocks, and they can form a kind of hierarchical structure. In such a case, the second block is indented in additional degree, and any given block ends when the number of indentations in the current line is less than the number that started that block. Let's take a look at this visualization here. So we can think of the main program as starting fully off to the top left of our code cell. And so the main program begins there. If we do an indentation, then we have created a code block that is inside of the main program. If we do another indentation, then we have created a second code block. Now everything in the second code block is still in code block 1 and it's also in the main program, right? And if we do another indentation, we can even have an even deeper level. But keep in mind that blocks can contain other blocks. And so everything is encased in the main program, right? And in code block 1, we have both all the code that is in code block 1 plus everything in code block 2 and code block 3. But notice here we can continue in code block 1 if we're still at the same level of indentation, right? And so the code block only ends when the indentation is farther over to the left than where it started. When we're using flow control, we can use several different kinds of statements to make decisions about what code should be executed or what code should be executed next. So here are several examples. We're going to look at each one in detail, but I'm going to give a brief overview of all of them first. So we can use an if statement, and an if statement is basically asking if this condition is filled, that is, if this is true, then complete this code, right? Complete this action next. An Elsif statement is saying if none of the previous conditions were met and this particular condition is met, execute this code. An else statement is saying if none of the above conditions were met, if everything else was false, then complete this particular action even if all of the other things above it are false. A while condition is saying while this condition remains true, keep doing this task over and over again in a loop format. And then a for condition is going to say execute in a loop for this many times. And then finally, a try statement is going to say try this, and if you get an error, then run the except code if that error occurs. Otherwise, just try it, and if it works, then just run that code and forget about the except code. So let's break down each of these flow control statements in detail. We're going to start with the if statement, the simplest one. And basically an if statement is just going to begin with an expression that evaluates to true or false. If it's true, then we're going to perform the action. If it's false, then we're going to skip over that action. And so it looks a little bit like this. If this is true, and then colon, and then indent, here's our code block that's going to have the Python code, and it's going to basically perform this action. Whatever Python code is in there is going to be executed. So let's put this into practice with a very simple program. So here's the flow chart for what that program is going to look like. We're going to start here, and we're going to ask the user if they're having a good day. And we're going to then take the user's input, and then we're going to evaluate the answer. And if the user put yes, we're going to print, glad to hear your day is going well, and then our program is going to come to an end. So there's basically one choice here. It's going to check to see if the user inputted yes, right? That's the check we're going to do. So here's the code here for how we're going to implement this. We're going to start by printing, are you having a good day? And then clarify yes or no. And so we're just printing a string using the print function here, so that's simple enough. Then we're going to create a variable, and it's just going to be called having good day. And that's going to be the user's input. And so when the user types in yes or no or whatever other thing they type in, that's going to go into the having good day variable, right? And so here is the actual if statement that we're going to use for our logic. And so we're going to say if having good day, and then notice here we've got two equal sign because we're doing a comparison operator. And so we're trying to see if having good day equals yes, or having good day equals yes. And so notice here strings are case sensitive. So I've put in a capital YES and I put in a lowercase YES. And so having this or here allows it to check for both. And if either one is true, then we're going to print glad to hear your day is going well with an exclamation point. And notice, of course, here's the indent that shows that this is a new code block and it's going to run our code. So let's run this code. Are you having a good day? I'm going to try first, I'm going to write no. And so if I write no, nothing is actually going to happen because the only check we did was to see if having good day equals capital YES or lowercase YES. And since neither of those conditions were met, our program just finished, right? Now, if we run this again, and this time I'm going to put in lowercase YES, and then I'm going to hit enter, it's going to respond with what we expected. Glad to hear your day is going well. And so it's just doing that simple check to see if that string matches the input, and then it's responding appropriately in this circumstance. Let's start to make our program a little bit more sophisticated. So we're going to use now an else statement. An else statement does not require a condition to evaluate to true or false. So when we did the if statement before, there was that kind of test and it says, is this true or is this false? An else statement executes no matter what if none of the previous conditions are met. And so the form basically looks like this. There's an else and then a colon, and then we have our code block to perform the action in Python, right? And so notice that there's no condition here. It just says else and then perform this action. So it's kind of like a catch-all, right? And so our new updated flowchart looks like this. It's going to start. We're going to ask the user if they're having a good day. The user is going to input an answer, and then we're going to evaluate that answer. If the answer is yes, then we're going to print, glad to hear your day is going well. Otherwise, it's going to say, I wish your day was going better. And it doesn't matter what the user puts in. If it's not yes, like capital Y yes or lowercase y yes, if it's not one of those two things, then this branch is going to execute every time. So it'll execute whether they put no, or if they put in some kind of random word, it'll also say this. The point is that it only executes yes, and then if we don't have a yes, then the other thing happens no matter what. Okay? So let's look at how this looks in practice, right? So we're going to start here with, are you having a good day, yes or no? Then we're going to take our variable having good day, and that's going to be the user's input. And so here's our if statement, like we had before. If having good day equals yes, or having good day equals lowercase y yes, then we're going to print glad to hear your day is going well. So that's what we had before. And then we're going to add this else statement. And the else statement, again, is just going to be a catch-all. It doesn't require something to evaluate to true or false. It's just saying if nothing else happened, nothing else was true and none of the other code got executed, then we're going to execute this, and it's just going to print, I wish your day was going better. So we'll run this code block, and I'm going to put in yes, just so we can verify that it still works, like the same way that our above example worked. And now I'm going to run the code again, and I'm going to put in no, and it's going to say, I wish your day was going better. Of course, we could put in also anything there. So are you having a good day? We could put in a random word, and then it would just say, I wish your day was going better. So it's not checking actually to see whether the user says no. It's just executing that else block, since we didn't get a true value that led to the previous if being executed, right? So of course, we'd like our program to be a little bit more robust. That is, we wanted to check whether the user actually inputs no. So we're going to use elif statements, which is just short for Elsif. And so an elif statement allows us to create a list of possible conditions where one, and only one, action will be executed. So elif statements come after an initial if, and then they're before a final else statement. And so the construction that we're going to create looks something like this. If condition A is true, perform action A. If condition B is true, perform action B. If condition C is true, perform action C. And so it's going to go through this list, and it's only going to execute one of those actions, right? And then if none of those are true, if in all of those conditions they're all false, it's going to finally use that catch-all, that else, and it's going to perform the final action for that else, right? And so let's look at a flowchart version of our program then. So it's going to start, it's going to ask the user if they are having a good day. The user is then going to input their answer, and then here's what our new program is going to do. It's going to evaluate the answer. If the user inputs yes, it's going to say, glad to hear your day is going well. If the user says no, it's going to say, sorry to hear that, I hope it gets better. And if they write something other than yes or no, it's going to do the catch-all, the else, and it's going to say, sorry, I only understand yes or no. And so it's going to give the user some feedback that they didn't give it the proper input, and then the program is going to end. So let's look at the code in this example. So first, we're going to print, are you having a good day, yes or no? And so we're prompting the user and telling them that we need that yes or no answer, right? We're going to have the having good day variable that's going to take the user's input. So all of this is the same so far. We're going to use an if statement first of all, and it's going to check for capital Y yes or lowercase y yes, and then if it gets a match there, if having good day does equal one of those things, it's going to print glad to hear your day is going well. That's familiar. Here's the new part. This is the Elsif statement, the elif statement. And so it's going to do the first if statement, and then the elif statement, it's going to say, is having good day equal to no, or is having good day equal to no with a lowercase n. And then it's going to print sorry to hear that, I hope it gets better. And then finally we have our catch-all, and our catch-all in this case is going to run, there's no condition, it's just else with a colon, and then it's going to print sorry, I only understand yes or no. So let's run that code. And so, are you having a good day? Let's try all of the conditions. We're going to do yes, glad to hear your day is going well. Let's run it again. Are you having a good day? We're going to type no, sorry to hear that, I hope it gets better. And then finally, let's run it one more time, and in this case we're going to put in a random word that is not yes or no and see how it responds. It says, sorry, I only understand yes or no. And so you can see, if you had a very long list of Elsif statements, that you could create some pretty intelligent logic in a way to respond to the user. One of the questions you might ask yourself is, what's the difference between an if and an Elsif? That is, why couldn't we just use a bunch of if statements for our tests above? The difference is this: when an Elsif condition is met, all the other Elsif statements are skipped over. This means that one, and only one, flow control statement is executed when using Elsif statements. The fact that only one Elsif statement is executed is important, because it may be possible for multiple flow control statements to be evaluated to be true. So a series of Elsif statements evaluates from top to bottom, only executing the first one that evaluates to true. The rest of the Elsif statements are skipped over, and it doesn't matter whether they're true or they're false, they're all skipped over. In practice, a set of mutually exclusive if statements will result in the same action as an if statement followed by else if statements. But there are a few good reasons why you would want to use else if statements. First of all, a series of else if statements helps someone reading your code understand that a single flow control choice is being made. It kind of groups them all together, and it makes it clear that there's one choice being made. Using else if statements will make your program run faster, since other conditional statements are skipped over after the first evaluates to true. Otherwise, every if statement will be evaluated. And finally, writing a mutually exclusive set of if statements can be very complex. And so this is a way of simplifying our code and making it easier. So let's expand on our concept of our how's your day going program, and let's take a look at an example that uses else if statements. And we're going to basically switch from else if statements to if statements and see the difference that makes in the program. So here's our new program, and it's going to take in two different inputs. So we're going to ask the user the day of the week. The user is going to give us an answer, and then we're going to ask the user if they are having a good week, and then the user is going to input an answer. Now, at that point, we're going to use those two answers that are stored in different variables. First, we're going to evaluate the day of the week, and if the day of the week is Friday, immediately we're just going to say, have a good weekend, enjoy the weekend. That's our response. If the day of the week is not Friday, then we're going to evaluate whether they're having a good week or not. And so if they're having a good week and they put in yes, we're going to say, I hope the rest of the week is good too. If they put in no, we're going to say, sorry to hear that. I hope the rest of the week is better. And then finally, for the else statement, that is, if they put something that's not yes or no, it's going to print, sorry, I only understand yes or no. Okay? And so this is a little bit more complex program, but let's talk through it, and then I can explain the difference between if and else if in this example. So first we print what day of the week is it, and then we take as input day of week, and so that's going to be the variable name that stores the day of the week. Then we're going to print, are you having a good week? And then they're going to answer either yes or no, hopefully. We're going to store that in having good week. And so here's the logic of our program. First, it's going to do if day of week equals Friday, or day of week equals Friday with a lowercase f, we're going to print enjoy the weekend. So that's this test right here. It's going to check and see if this is Friday. If it is Friday, then it's going to print enjoy the weekend. Then we have two else if statements, and so the first one is if having good week equals yes, then it's going to print I hope the rest of the week is good too. So that's our first branch up here. Else if having good week equals no, it's going to say sorry to hear that, I hope the rest of the week is better. That's our middle branch here. And then finally with our else, our kind of catch-all, it's going to print sorry, I only understand yes or no. Okay, so let's run our program. What day of the week is it? Let's say it is Tuesday. And so are you having a good week? Yeah, I'm having a good week. So I'm going to put in yes. And it says I hope the rest of the week is good too. Great. So let's try an example where it's Friday. And then it's still going to prompt us for are you having a good week? So it hasn't, this part of the program where it evaluates our logic hasn't happened yet. We're still up here. And so are you having a good week? I'm going to say no. It doesn't actually matter because it's not going to take that into account, because as soon as it realizes that it is Friday, it's going to say enjoy the weekend. And so we have the Friday here, and so none of the other things, even if they're true, are going to be executed. So even though this no was true, it's not going to be executed because it's going to just check the Friday thing, and since that is true first, it's going to execute that, right? Now let's try this. Let's change these else ifs over to ifs and see what difference that makes in our program and see if we can explain that. So we're going to change the else ifs to if statements, and then we're going to try and input Friday and yes and see what happens. And so I'm going to run that. What day of the week is it? It's Friday. Are you having a good week? I'm going to put yes. And now we get this confusing thing. It says enjoy the weekend, which makes sense. And then it says I hope the rest of the week is good too. And then it also says sorry, I only understand yes or no. So suddenly our logic has been broken in our program, and we can tell why if we look at what it's doing. So first of all, it's doing this if statement, and it's doing that check. If the day of the week is Friday, it's going to print enjoy the weekend. So that if statement is true, it's going to print that. It's going to do the second one to see if it's a yes, and that is also a yes. And so it's going to print the second one as well. And then finally, it's going to do this next if statement to see if having good week equals no. In this case, this is not true, so it's not going to execute that. But then this else statement is going to get lumped in with this last if statement, and so it's going to print this sorry, I only understand yes or no as well. And so you can see that this has kind of fundamentally broken our program because it no longer just executes one statement. Suddenly it's treating each one of those as an individual choice, and that may be what you want depending on your program. But in this case, we just want a single choice to be made, and so by using an if followed by else ifs, we tell the program that we just want to make one choice here. If it's a series of different choices, then you might use a bunch of if statements. But if you just want one choice to be made and you just want the first thing that happens to be true to be run, then you want to use else if statements. So far we've used if, else if, and else statements to basically be kind of like a decision-making branch to decide what action should be taken next. Sometimes, however, we want to repeat an action over and over again. We want to do a loop rather than kind of picking one decision-making branch. And so we're going to talk about while loop statements. And so the while loop statement loops a particular action over and over again until some condition is met. This is what it looks like. While this condition is true, colon, and then we have an indent with our code block, take this action. And so the action is taken, and then that changes something that allows us then to go back to the beginning and check the condition to see if it's true. As long as the condition remains true, the loop continues to happen. So let's take a look at an example program here. So we're going to start the program. We're going to ask the user to guess a secret number, basically. The user is going to input a guess, and then we're going to evaluate the guess. If the user gets the number correct, we're just going to print a congratulations message that they guessed the number, and the program is going to end. If the user inputs the wrong number, then we're going to start the loop, and it's going to print a guess again message, and then the user is going to be able to input another guess. And so this kind of section right here is going to repeat over and over again as the user guesses over and over until they get the correct number, and then it's going to print the congratulations message. So let's look at what this looks like in Python code. So first of all, we're going to have to create a secret number that the user is going to guess. Here we're just going to set it to 4. We could set it to whatever we wanted. It doesn't matter here. We could also use another function that creates a random number. But here we're just going to set it equal to 4. You can change that in the program if you like. We're going to print, I am thinking of a number between 1 and 10. Can you guess it? And then the user is going to input a number, and that's going to be stored in a variable called guess. And so while guess does not equal the secret number, and here notice we're going to use the stir function, because when the user inputs a guess, it's going to be in the form of a string. So we're going to change our original secret number, which is an integer, into a string here to do our comparison. And so while the guess does not equal the secret number, we're going to print nope, guess again, and then they're going to put basically another guess into the input, and then we're going to go around and do the loop over and over again. Finally, when the guess does equal the secret number, then the loop is essentially going to end, and we're going to print you guessed the secret number, and then here we'll also include the secret number that they guessed. So let's run this code. So I am thinking of a secret number between 1 and 10. I'm going to type 1, nope, guess again. 2, nope, guess again. 3, nope, guess again. And then 4, and then you guess the secret number 4. And so the loop is happening over and over again. That's how a while loop works. And then once the condition is met, then it exits out of the loop and then goes on to the next thing to be executed. A while loop can create a big problem in our code. That is, what if the condition is never met? Then the loop will continue over and over again without stopping, right? And so it's possible to create an infinite loop that never ends. If you accidentally write code that infinitely repeats, you can stop the execution by selecting interrupt from the kernel menu. So you can come up here to kernel, select interrupt, and it will stop that loop from repeating, and the code cell will stop executing, and that will stop your problem. So then, depending on the output, you may get a lot of output. You can go up to cell and then go to current output for the code cell that you're in, and then clear, and that will clear the output. So here's an example of what that looks like. We're going to do this while loop, and the while loop is just going to say while true, and so there's not going to be anything that's going to change it to false. It's just going to always be true. While true, we're going to print oh no's, and so that's going to create an infinite loop. And so basically it's being printed over and over again. It's continuing to print at this moment. I'm going to go up to kernel, and then I'm going to go to interrupt, and notice now we get a number here that says this code cell has stopped executing. So now that it's stopped executing, sometimes it can use up a lot of space. If we want to get that space back, we can go up here, and then we can go to current outputs and then clear, and that will clear the output for that particular cell. Another thing that you can do instead of going up to kernel and then interrupt is you can select the cell that is going rogue, and you can press I, the letter I, twice for interrupt, and that will do the same thing. So I'll just demonstrate that. It's running. I can then push I on my keyboard twice, and it stops it from running. And then I can fix the error. I can look at my code and see what the error is that's creating the infinite loop. There's actually a more powerful way to repeat a loop a certain number of times, and that's with a for loop statement with a range function. And so the form that this takes is for I in range j, take this action. I is just a generic variable. We can make that variable I or anything else. J is the number of times that we want this loop to repeat. And so the starting value of I is always 0, and then each time it increases by 1. So here's a for loop that repeats what 5 times. For I in range 5, print what. And so I'm going to run that code, and you can see it just prints what 5 times. We could change this I to be anything. We could call it number like we did above. It doesn't make a difference. It's just the variable name that is going to hold what iteration we're on. So it's going to start at 0 and it's going to count up to whatever number we put in this range here. So by convention in Python, this is I, but you can call that whatever you want. And then we can change this range number to be something different. If we wanted the loop to go through 7 times, we could put in a 7 there and it'll print out what 7 times. And then we can also print out those iterations if we wanted. So for instance, we can reference that I variable. So for I in range 5, print I. And so we're going to run that code. And I always starts with 0 and then it counts up. Once I gets to the value of 5, it's going to stop. So we're going to get 0, 1, 2, 3, 4. And there's our 5 iterations. Now, in the examples above, the range function takes a single argument that specifies the number of loops. So that's our j variable that we put in there, right? And the assumption in our range function will start at 0, but we can specify a different integer by adding an additional argument that we pass in. So for here, I have for I in range, and then I've got 27, 32, print I. So we're going to start at 27 and we're going to go up to 32. And so by specifying that additional argument, we can specify the starting point and also the ending point. We can even specify a negative starting point up to a positive ending point. And so for here we have for I in range -3, 7, print I, and so that's going to start at -3 and iterate up 1 each time all the way up until 6, right? And so finally, we can also change the amount that it increments each time. So we've been adding 1 each time. We could subtract 1 if we wanted, or we could subtract 2, or we could add 3. We can do whatever we want. And so in this final example, we have for I in range 10, 0, -1. We're going to print I and then print go. So this is going to start at 10. That's going to be our starting point. And then it's going to end at 0. And then it's going to increment by -1. So we can specify those things in that order. The starting point, the ending point, and then the increment, or I guess you could call it the decrement in this case. And then if we run this code, we're going to get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then finally I just added the go because, yeah, it's got to be there, right? Let me show you one more trick with while loops. So while loops and for loops can also use continue and break statements to affect flow control. A continue statement immediately restarts a loop, and a break statement immediately exits the loop and ends that loop process. So let's return to our secret number guessing program. And so we're going to do exactly the same program, but we're going to use continue and break statements to make it happen. So we start the program, we ask the user to guess the number, they input a guess, and then we have this loop when they're getting the guess wrong, and when they get the guess right, we print the congratulations message, and that's the end. So here's what that looks like with continue and break statements. So first of all, we're going to set the guess that the user is going to choose to 0, and that's just an initial guess, and of course it's not going to be right. We're going to set our secret number initially to 4, and we're actually going to convert that immediately to a string just to make things a little bit easier. And we're going to print, I am thinking of a number between 1 and 10, and this is essentially asking the user to make a guess. And then here's our new logic, here's our new code, which is a little bit simpler. While true, we're going to print what is your guess. They're going to input their guess, and it's going to be the new value of guess. So we started with 0. Whatever they put in is going to be the new value for guess. And then if guess equals the secret number, we're going to immediately break. And so that break is going to essentially end this while loop. It's going to take us down here, and it's going to say you guessed the secret number, and then print it out. Else, it's going to continue. And so continue in this case doesn't mean continue on to the next part of the code. It means continue doing a loop. And so that can be sometimes confusing to people the first time they see it, because they think continue means continue to the next thing in the code. Continue means continue doing the loop, and break means break out of the loop and then run the next code. So let's execute this and see what that looks like in practice. I am thinking of a number between 1 and 10. What is your guess? I'm going to put 1, and then it's just going to execute the loop again. What is your guess? 3. And so when I finally put in 4, it says you guess the secret number 4, and so that's when that break happens. Is if the guess equals the secret number, then the break happens, and it prints out you guess the secret number. We have one final example of flow control, and it's really a matter of error control, and that's exception handling with try and except. So when running code that may create an error, we can use try and except statements to stop a program from crashing. So here's an example of what might crash a program. We can divide by the number 0, and that's going to create an error, right? If we divide by the number 0, we're going to get a division by 0 error, and that's going to be a problem. We can see that a problem might be coming, and so we can write in exceptions so that if an error happens, that we protect against the user getting an error. And so here we have a program that's going to essentially do the same thing, except it's going to take user input to figure out what number we should divide by. So we're going to take 100 divided by some number, and the user is going to input that number. And so for almost any number, we're going to be okay, but if the user inputs 0, we're going to have a problem. It's going to create that error, right? And so we're going to print 100 divided by. The user is going to input this number, which we're going to store in something called user number. And we're going to try to print 100 divided by whatever number the user puts in. Of course, here I'm using an integer function to change that string that the user inputs into an integer. And so it's going to try and divide that out. And if it gets an error, then it's going to print you can't divide by 0, because we know that, or we believe that the error will be caused by 0, right? So if I run this program, 100 divided by, so I can do something like 25, and it's going to give me 4 back. And then if I run this program and I put in a 0, it's going to, instead of giving them an error like we saw below here, it's going to say you can't divide by 0, and so it's going to run that exception. And so this is a way of making your code more robust and foreseeing problems that your users might run into and then giving them helpful feedback. All right, we have covered a ton of ground with flow control statements. We've done if statements that check to see if a condition is fulfilled. We've done Elsif. We've done else to create essentially a list of choices for our program to choose from. We've done while statements that execute loops over and over again. We've used for statements with range functions to repeat a loop a certain number of times. And we've done try except in order to figure out how to make our programs more friendly to users and to stop errors from happening. So we've covered a lot of ground. Take some time to play with this code and to really make sure you understand all these different types of flow control before moving on to the next section. So we've discussed native Python functions, but now we're going to talk a little bit about how to write your own functions. So in the above examples, we use things like the print function or the input function or the range function. Now we're going to create our own. The function definition statement looks like this. It starts with def, then we name the function, then we have 2 parentheses, a colon, and then we define the function under that in a code block. So that's just the definition, right? After we define the function, we still need to call the function to make it actually do the work that we want it to do. So we define the function first, and then later on, when we need that function, we call it and then pass in any parameters that might go along with that function. So let's look at an example here. We're going to create a simple function that's going to double a number. And so first of all, we're going to print, I will double any number, give me a number. And we're going to create a variable called input number. And we're going to use the input function, the native input function, to store that number in input number. And then here's where we're defining the function. So we're going to define it. Here we're just going to call it my function. We can call it anything we want. Obviously it's better if it's descriptive. And then this is what it's going to do. It's going to take output number, which is a new variable we're going to define, and it's going to be equal to the input number as an integer. Remember, when we take things in with the input function, they come in as strings. It's it's going to turn the input number into an integer, and it's going to multiply that by 2 and set that value equal to output number, and then print output number. So this is just the definition. To actually make it happen, we have to call my function. And so here we call my function, and it actually runs. And then in this case, we're going to print give me a new number. And then we are going to have them input a new number. And instead of having to write all of that code again that is going to double the number, we just call the same function over again. It saves us a ton of work. And then later on, let's say we want to change the code, it'll make it even easier. So then finally we can do it one more time. So basically we call this function 3 times, and each time it doubles the number for us. I'm going to run that. I will double any number, give me a number. I'm going to say 12. So it doubled 12 and gave me 24, and then it asked for a new number. So I'm going to do 10. Here I get 20. Give me one last number. I'm going to do 50. It gives me 100. So I've been able to run this code 3 times without having to basically write the same code out 3 times. It's going to save me a ton of work. So I've created my function that doubles a number, but maybe later on I decide actually I don't want to double a number. I want to square the number. So then all I have to do is make a change to that one function that I've defined, that single source of truth, and then it will change it in all 3 spots, right? Because that function is getting called, it's going to refer back to the function definition, and that way it's very easy for me to maintain my code. My code isn't duplicated in a bunch of different spots. In fact, a lot of programmers spend time deduplicating their code, trying to take out duplication so that a function is just defined in one spot, and then it's easy to change across the whole code base. So here's our original program with the function, and here it's being multiplied by 2. Now I'm going to add an extra asterisk here, and that's going to raise it to the 2nd power instead of multiplying it by 2. And so I can change this to be, instead of doubling any number, I will raise any number to the 2nd power. Okay, it's important that we update our description so that it's accurate, and when people see the code, they'll know what it does. And so now let's run this, and we will see if it does as we wish. So I'm going to give it 4. It's going to give me 16. I'm going to give it 12, 144. I'm going to give it 10, and it gives me back 100. So with that simple change, I've changed the way the function runs in 3 different spots. It's made my life a lot easier. We've talked a little bit about what it means to pass an argument into a function. That is, we take an integer or float or something, or a text string, and we pass it into the parentheses, and it goes into the function, and then we get some kind of output back out. But there's another word that kind of describes what goes in those parentheses. That's a parameter. And this can be confusing to people if they're new to programming. What's the difference between a parameter and an argument? So this essentially is it. A parameter is what we call the definition that goes inside those parentheses when we're defining the function. So when we write that definition statement, so we write definition, my function, and then the input variable. Input variable here is a parameter. And it's a parameter because it's what it's being called as the function's being defined. But when we're actually passing in a value, when a value is actually being passed in the function is being called, and a value is being passed in, that is an argument. And so the difference essentially is that when we're defining a function, we call it a parameter. When we're actually passing a value in, we call it an argument. Now let's say we want our function to return some kind of value. We want to put some value in and pass it as an argument, and then we want to get some value back from our function. Whether or not a function takes an argument, it will always return a value. if there's kind of no immediately noticeable value, it's returning a none, which is a special kind of value like the Boolean true or false that simply means null or nothing. It's not the same thing as like 0 or anything like that. It's a special value like true or false, and it is none. So we can also specify return values for our function using a flow control statement, and we use that using return. So here's an example. We're going to do a fortune teller program, and so here we're going to define the function for our fortune picker. And so we're defining fortune picker, and then we have a parameter here. It's fortune number, and so we're going to pass in a value here. It's going to be an integer. And then we have some flow control here. We have an if statement, some else if statements, and then essentially if the value is 1, it's going to return this text string. If the value is 2, it's going to return this text string. And so we're going to pass in an integer, and then this function is going to return a text string. So at the bottom here we have a print function, and then the function fortune picker, and then we're going to put in 3 here. We could use a random integer creator here, but here we're just passing in the integer 3. If we wanted to return a different fortune, then we would put in a different number here. So essentially what this is doing is when I run that, it will print back, that is, it will return fortune number 3. And so fortune 3 here is a new friend will help you find yourself. And so I can pass in something else. I can put in 5. And then it's going to go to our branch number 5 here, and it's going to say that promising venture, it is a trap. So that's kind of ominous. But you can see that we're passing in an argument into this function, and then we're getting a return value in the form of a string. So in our next iteration of the fortune teller program here, we just have a slight embellishment, and so this time instead of just supplying the number in the code itself, we use a random number picker. And so we import randint from random, and randint is just going to pick a random integer. We specify kind of the 2 numbers that we want that random integer to be between. So we define a function here, random number, and then randint picks a number between 1 and 6, and then we put in that random number into our fortune picker function. And so however many times we run this, it's going to randomly pick a fortune 1 through 6. And so the first time I get the fortune, you will become very wise. If I run it again, it says sort yourself out, then find love. That's some good advice. And then so each time I run this fortune picker, it's giving me a new fortune, just using this randint function to pick a random number between 1 and 6. Do not eat the sushi. So using functions is going to make our lives a lot easier by avoiding duplication. One of the most dangerous areas where things can be duplicated, though, is with variable names. As your code gets longer and longer and your program becomes more complex, there's a serious danger that somebody will call a variable the same thing in 2 different places, and the variables will get mixed up, right? And so to alleviate this problem, we have a concept of local and global scope. And so we use the phrase local scope to describe what happens within a function. The local scope of a function may contain local variable, but once that function has completed, once it's exited out, the local variable and their contents are completely erased. And so on the other hand, we can also create global variables which have a scope both outside of the function and inside of the function. That is at the top level of the program and within all of the functions that are defined, right? And so this is the way to think of it. In the global scope, Python does not recognize any local variable from within functions. So when we're at that top level, we're not running inside of a function. That means that Python is not going to recognize any local variables that are happening within functions. In the local scope of a function, Python can recognize and modify any global variables. So those global variables have a global scope. That you can access them anywhere, right? And it is possible for there to be a global variable and a local variable with the same name. So keep that in mind. The idea is to try and stop collisions. And so the local variable is always privileged. And so what happens is the local variable will be changed if you're working within the local scope. But if we go back out to the global scope and it has the same variable name, then it will work with the global variable because the local variable will be wiped out. Remember, when we exit a function, the local variable is wiped out. It doesn't exist anymore. Ideally, Python programs should limit the number of global variables and create most variables in a local scope. So there's less opportunity for kind of collisions between variables with the same name. So let's look at this example here. We've got a global secret number. That's the name of our variable here. We're going to call it, we're going to set it equal to the integer 7. And then we've got a function here, and the function is called share number. And then we've got a variable inside of the function. So this is going to be a local variable, and it's called local secret number, and that's equal to 13. And so when we call this function, it's going to print the global secret number is, and then it's going to print the global secret number, and then it's going to print the local secret number is, and then it's going to print that local secret number. So this is just the definition. It doesn't run the code. We have to call the function first. So here's where the function is actually being called. This is where it will actually execute. And so what should happen there is these should both print out, right? Because we'll be in the local scope when this share number function is called. Then after that, we're in the global scope. Notice that we're all the way to the left hand. We're not within a code block within this kind of function definition. We're all the way over here, so we're in the global scope. And it's going to say the global secret number is, and then we're going to try and print the global secret number. And then it's going to print the local secret number is, and then it's going to try and print the local secret number. So let's run this code, and then we can take a look and see what happens. So when we run the original share number function, it's going to work as expected. We're going to get the global secret number is going to print out, the local secret number is going to print out. When we try and print it in the global scope, we're going to have a problem. And the reason we have a problem is because the global secret number is obviously going to work because it has a global scope with that variable. But when we try and print the local secret number, which is defined in that function, since we already exited out of that function, that variable was destroyed. It doesn't exist anymore, right? And so we get an error here. We get a name error, and it says local secret number is not defined. And so this is an important demonstration of what happens when functions come to a close. All the local variables that are created in that scope are no longer accessible, so keep that in mind. So what does happen when we create two variables, one a local variable and one a global variable with the same name? Let's take a quick look at that so you can get a sense of what would happen in that circumstance. So in this example here, we have a variable called secret number. It's equal to 7. That's my favorite number. And then we're going to create a function here, and it's going to be called share number. And then it's going to have also a variable called secret number, except the secret number in our function is going to be 10. And so the global secret number is 7, and the local secret number is 10. And so it's going to print the secret number at the end of this function. And then we're going to run that function. So this is just the definition again. We define the function here. To actually run that function, we have to call it here. And so we run share number, and then we're going to print secret number. So let's run this code, and then we can explain exactly what's happening here. So we get 10 and then 7. And so this is what's happening essentially. The first time when we run the share number function, it's going to go inside this function, and it's going to print secret number, and secret number in that local scope is going to have privilege. That is, even though there's a secret number that's a global variable and a secret number that's a local variable, within this function, when this function is running, it's going to privilege the local variable, right? And so first it's going to print out 10 when we do that print inside of the share number function. Once that function closes, the secret number that is the local variable evaporates, it's gone. So all that is left is the secret number that is the global variable. And so when we have print secret number after that, it's going to reference the secret number up top, the global variable secret number, and we're going to get 7. As one final note, I would be remiss if I didn't mention there is a way to create a global variable in a local scope, and that's with a global statement. So this is an example of a global statement here. We are going to start with a variable called secret number. It's going to be equal to 7. And then we're going to define a function called share number. And then we're going to say global secret number. And so this is indicates that this is the global variable. It's not a local variable. So when I say global secret number, it's going to change that this secret number out here, the global secret number. And so when we reset it, so here's an initialization statement. We're gonna change the value of secret number to 10. It's gonna print the secret number, and then we'll print it again after the function runs. And so you'll see in this case that when we run this, we're gonna get 10 both times because we did this global statement that essentially says we're not creating a new variable secret number. I want you to reference the global variable, and so we're making that indication with a global statement. That's it, folks. You've completed Python Basics 2. I know this was a tricky one, working with functions and also with flow control. Take some time, review this code, play with this code. Don't assume that you've got these techniques under control just because you watch this video. You need to play with the code and try and write some new things from scratch to test out your skills. After you've finished and you feel like you have a good mastery of these concepts, head on to Python Basics 3, where we're going to talk about lists and dictionaries.